Hello everyone. Welcome to the webinar using FME and the SpatialBiz Plug-in with Smallworld data, done in cooperation with Spatial Business Systems and Terra. My name is Marcel Sprotte. I'm a consultant at Terra, and with me today is Andy Street, the VP of Technology from Spatial Business Systems. Good morning, Andy.
Good morning.
So I would like to have a brief talk about our companies, and then I'll give control to Andy, who is basically presenting the technical part of the webinar and the FME Spatial Biz Plug-in. And after that, we will have some time for questions and answers, and then we will see how that will work out. So Spatial Business Systems is a full-service solution provider in geospatial technologies in the telecommunications, government, and utility markets. They are doing management consulting and detailed technical delivery services all along. They are in a very deep partnership with Safe Software since 2003, and their head office is in Lakewood, Colorado in the US. And us, we are Terra. We are the platinum partner of Safe Software. We are the European FME Service Center, part of the Esri Germany group. We are basically providing a wide range of geo-IT solutions and innovative products for private and for the private sector and public agencies. We are based in Münster, and we are about 110 employees at the moment. For the proceeding, we basically would like to ask you to ask questions all the time you want in the control panel of the GoToWebinar meeting. Just type in your questions and we will try to answer them at the end of the webinar. In case we cannot answer your question because it's maybe too detailed or we don't have enough time, we will answer all questions via email afterwards. Within this email you will also find the link to the webinar recording as well, so that you can check everything afterwards. So that would be it from me for now. I would like to hand over to Andy. Andy, I will give you the screen sharing. And okay. So, Andy, you want to take over?
Oh, sorry, I was on mute. I was talking to you, but I was on mute.
Okay.
Didn't realize. Hi. Yeah, I'm good to go. So thank you very much for that. So can you see my screen? Okay.
That's fine.
Okay, good. All right. So basically, I'm going to do a few little demos of the SpatialBiz plugin, just so you get a feel for how it works and how you use it. I'm going to show one slide just as a startup. This is basically an overview of the architecture of the SpatialBiz FME plugin. It comes in two parts: a server component, which is developed in Magic, which basically deals with reading data from the Smallworld database and writing data back in. It interacts with the ACE, with the various GIS partitions, and it exposes data to the C++ client, which is developed as a DLL, which is an FME plugin, which allows it to then work within the FME range of products like FME Desktop, Workbench, Viewer, or FME Server. So basically, just so you have an understanding here, there's two parts. The server, which is in Magic, which can be on any Smallworld compliant machine. It basically runs, and the connection is then made through the DLL via TICS, which can be on different client machines. The two don't have to be on the same time. You don't have to do anything to the server other than just set it up and get it running, and then you can connect from anywhere on your network. So basically, when you start off, I'm just going. I'm going to generate a new workspace just to show you some of the information. You select off the list of formats, and SBS plugin for Smallworld is the the SpatialBiz plugin. I click on parameters, and it gives me information about how I connect. So the server, the service, which is basically an alias for the port number that I'm connecting on, and I then have various constraints: features, worlds, predicates, search areas, and then a number of choice items down here that are of interest. So if I click on the list of choices here, okay, it just comes back with a list of the objects that I can see that I can go ahead and select against. So various databases, the database, and then the name of the collection listed afterwards. So I can scroll down and pick up whatever choices I want from there. If I wanted to, I can say use external names. So now when I click on here, rather than showing me the internal table names, it's going to show me the external names of the records of the collections and the tables that are within those databases. It also then uses the external names for the actual fields as well when they're brought out. So now when I scroll down, I see information displayed using the actual true internal name, or external name rather. Spaces are replaced with underscores to keep it compliant with other FME naming conventions. Other choices here, I can specify intermediate tables. So if I wanted to see that, what that will do now is it will show me join tables. So this is basically the intersection tables for many-to-many joins. It also then exposes internal join-related fields. So here I have, on the demographics database, I have a table called int, plink, sector, pie chart. This is actually an intersection table between the sector and the pie chart table, which I can now expose the contents of so I could work against it if I wanted to. So I'm going to open up a workspace I've already created. If I use export demo 1, okay, so this is one I've created already. It's basically taking data from Smallworld, connecting to my local connection, and I'm reading information out and I'm writing it to an FFS file, which is FME's internal format. So basically it's just a nice, easy to use mechanism for exporting data. I'm currently redirecting to the inspector application just because I want to show you what information is coming out. I've selected 3 tables: the min road, the park, and the hotel. I hit the go button. It connects up to the Smallworld system as indicated in the server and the service information here. It reads all the data out of the database. This is only a very small database, but it's just useful for showing the concepts. So basically here I have some information. This is the Cambridge database from within that comes with as a standard with the Smallworld installations. So as I zoom down here, I've got various bits of objects, etc. I've selected here a feature type called GIS Hotel. So basically I get all the attributes that are contained within the table. There's some additional ones as well. I'll get to those in a minute. But basically what I want to do is show you some of the more information that's actually exposed with this object. Okay, there are 2 geometries associated with this hotel record. So one read of the database has returned two geometries which are kind of concatenated or stored together as a complex geometry type. The first geometry is called location, and it has an X and a Y of that. Also as well, associated with the geometry are a number of traits. Traits are basically geometry attributes within FME, and I use these within the SpatialBiz plugin to hold additional metadata about the geometry, which is not readily supported by other geometry formats, i.e. the universe ID and the world ID tells me that this location geometry for this hotel is stored in the normal GIS 00 world universe or universe world combination. So basically, if I want to read data from a world or write data to a specific world, all I have to do is set the traits universe ID and world ID appropriately, and the data will then be sent to that actual world as if you were creating it within the Smallworld environment. In addition, I also have some topology information. If I go back to my options here, export topology is set to yes in my workspace, and because of that, every geometry that that exists on a manifold in Smallworld will have some information pulled out. It will indicate the network ID, which is the manifold number. To those literate with Smallworld, it's the manifold code, and it also displays the X and the Y of the node as well as the ID of the node. If I select a road, the name is centerline. The geometry will then support a number of nodes organized as a list attribute, as an FME list attribute, and the number of links that indicate information indicating this node is connected to this node. So this road here has 3 nodes, node 0, node 1, and node 2. So presumably there's one at one end, one in the middle, and then one at the other end over here. This is telling me the X and the Y, and the links telling me the nodes they go between. So basically this information that we pull out from Smallworld can be sent to another system or other systems to build network models in other databases. Okay. In addition, on the roads, we're pulling out some ID information. So here we have the actual ID of the road itself, but we can actually pull out join-related information here. So I have road annotations. It's going to show me the name of the road that's associated to that. If I click on the hotel, I'm not seeing it. Okay, doesn't matter. I'll get to joins later on. I have an example of building joins within Smallworld. So this retrieval that I ran here basically took all of the data from this very small database. What I'm going to do now is actually modify it.
Andy?
Yeah.
Sorry for interrupting. Would you be able to go full screen with your workbench?
Sure.
Ah, okay. Thank you.
Is that better? There's not a lot to see on there, but I have to pull some other things here. So basically what I'm going to do now is my little script here, but it's easier for me to copy. If I say to the road, I want to pull out roads, but I want to pull them out where the road type is equal to B road. So rather than pulling all of them, in this case I'm just going to pull out roads that are part of, that are flagged as being on the, as being B roads. So now when I run the translation, I'm going to get less roads being pulled out. So now the other designation of roads are being ignored, and all I'm getting is, in this case, is now B roads. So looking at the data, they should all be B road types down here. I can specify boundaries, min X, min Y, height and width, or max X, max Y if I want to do like a screen extent that way, or I could use this control here. So basically this spatial datum and the interaction and the buffer, this allows me to define a spatial predicate which is fired at Smallworld, and it says, I only want you to pull out the features for which this spatial predicate is satisfied. So, as an example, okay, I'm just saying, go to the GIS database, to the town table, and find me coverages where the name of it, which is an attribute of the town object, is equal to Impington. So basically I'm saying, I only want you to pull out roads, parks, and hotels where their geometry interacts with towns called Impington. So now when I run the query, it's going to come back with a smaller set of features. I don't think there are any hotels that in this town of Impington, but basically using a predicate which is looking at features that are within the database itself. So it's a kind of a dynamic read on the fly. Okay, I'm just going to remove this again, just because I want to go back to showing you something else related to this workspace. Okay, so there's my original extract set. And the reason I wanted to go back to this one is because I need to query some hotels and just show you some information about some hotels. So I've selected a hotel annotation there. Actually, no, I'm sorry. Yeah, it is. Okay. So here's the hotel. And there are two attributes on the end here called color and connected road. Now these attributes don't actually exist on the exemplar in Smallworld. So if I come over to Smallworld and I go and find my hotels, so the attributes on the hotel are name, address, address to, and type, comments, locations, and annotations, but no other information. Actually, I'm just going to change this to Google. Okay. So the attributes there are just the information there. But here I've got additional attributes, color and connected road. Now, the way that we expose that, and this is just a little bit of magic code, so for those of you literate with magic code, this would be interesting to you. The others, just ignore it. So basically, this is some configuration that we can put in on the FME plugin so that we can set up things as a standard for when we're working. And typically, when we're doing conversion projects for customers or setting this up for customers, we would help them define a set of standards for themselves. Included in this are things like the global coordinate system. So in this case, the Smallworld database uses a British National Grid coordinate system in millimeters. Obviously, no one else knows about millimeters as a coordinate system unit. So we basically project everything into meters, and we do it through this proxy directly. We could set it up within the workspace using here and putting in projectors within here and defining a custom coordinate system within FME. But typically, I find it's faster. The process runs faster if I just set it up in the magic code. And once I have this here, everything I interact with now is all in meters. So reading, writing, querying, everything is all meters, and it's all using the industry standard. So I don't have to worry about any incompatibilities between millimeters or centimeters or inches or feet or whatever. I just say it's all set up for me. But what I want to show you down here, some of the custom information. So here's some custom behavior. So I'm defining FME pseudo field definitions, and I'm calling it color and connected road. Color is a string, 10 characters long. Connected road is an integer, and there's only one of it. It's not a vector. The method that underlies this connected road is then read as a derived field. So basically, it's a way of exposing a logical or derived field to FME without having to place it in the data model. So the connected road here, what it does is it looks at the location object, looks for connected chains, finds a connected chain, which in this case is only roads, and returns the ID of the first one it finds. The color method looks at the location geometry, if it exists. It opens up the style system based on a set of information associated with the style, the ACE name, the SOC, the display scale, a drawing application name, style family. It basically goes off and it looks through the color for that's been set in the style system and displays it to me, so I can see that that is the information associated with that. So we can pull out not just physical data, we can pull out relational data, metadata associated with the style database, with the ACE database, whatever you want. You can tag that onto those features as well if you wish, or you can create virtual geometries as well. And we've done that in a number of cases where you basically can create a pseudo geometry and expose it in FME. It then becomes part of your translation to be sent out. Okay. That's enough on that one. I'm going to talk about another workspace now. So now I'm going to open another workspace, export demo 2. So this is a somewhat simple workspace. What basically it's doing is looking at the same database, but it's looking at the electric database. This time it's looking at a substation object. And what I want to do in here is basically control the retrieval by using feature readers. So feature readers in FME are transformers that allow you to inject features into a workspace based on a predicate and based on a kind of reader. So in this case, the only thing I'm reading initially is substations, but then for each substation I read, I send it to this feature reader, which then is told to do the following. What it does is it says, I want to find substation internals, electricity.substation internals, that's database collection, where the substation ID is equal to the value of ID. ID is the ID of the substation coming in. So basically what it's saying is, as I read a substation, I then want to go and find substation internals, which are a child feature, which are related to that substation. So basically it's a way of limiting a retrieval to say I only want to get the children. And when I've got them, I do some interaction with them and basically send them out to substation internals. This one down here, what this does is it says for each substation internals that I read, I then want to go and get the switches and the transformers which sit in its internal world. So this is interesting Workspace only for two respects. Basically, the first is that it's using a feature reader. The second is that it's demonstrating the ability to read data from multiple worlds at the same time. So when we read complex objects, we pull all the geometry from the feature. So when I scroll in on this area down here, this is the internal world for the substation that I found. Its coordinates are all down in the zeros. 0, 0, 1,000, 1,000, blah, blah, blah. The substation itself is up here in the projected coordinate system. All of the data comes out together. And it's up to me then to decide what I want to do with the geometries. So in this case, in my workspace, I would take the substation, I would deaggregate its geometry, sending one geometry to one collection or one table, be an external world table or whatever, and the other geometries would go to an internal world drawing file or whatever I wanted to do with the output results. But basically here, I have my two geometries, an annotation geometry, and the location geometry, which is actually a boundary, I believe. And also I have the information on the substation that tells me the number of the world that it owns. So basically, I can, by running this thing here, as I get one substation, it sends down here, it initiates the reading of one substation internals object, which then itself initiates the reading of the 3 switches and the 1 transformer that sit within it. So I only bring this workspace up just as an example to show you, how you can do dependent retrievals, predicated and dependent retrievals using feature readers. This is quite a powerful way of dynamically changing and reading data from a small world environment. So I'm going to go on to another workspace now. This one's going to be a synchronization one. Okay, so this is, again, another simple one. This workspace this time is using the external names. So I see all the names of the attributes inside it are all external, known as voltage, status, length, whatever. So basically, my interactions with these objects are all using external table names, external field names. Obviously, the values are the normal values, but using that external name allows me to cross-language differences between internal names of models and external names used by different customers. But what we're doing here is we are reading data from Smallworld and we're writing it to Oracle. So this is part of our synchronization suite. We call it sync. But basically, what we do is we actually take changes. So if I hit the run button here, connects to Smallworld, it does some stuff in an alternative, and it says nothing has changed. What I can see down here when I look at it in here is my alternative is FME sync. My checkpoint is called sync, and I am synchronizing with set to yes. So basically what this means is it will only read data in this FME sync alternative, which has changed with respect to the latest checkpoint called sync. And if I go into this, I'll show you what it looks like just really quickly. If I go into sync, I'll see I've got a series of checkpoints called sync and then a date timestamp afterwards. It looks at the latest of those and looks for changes related to that. So if I come back up into the FME alternative and I go writable in my database, I'm just going to update that record. Okay, so just made some changes there. Just a number of changes. Oh, actually, no, I'll just delete a record as well. Let me just do that. Okay, so there's some changes made in this alternative. It's the parent alternative. In this FME alternative, when the synchronization process runs, the first thing it does is it merges into the child alternative, into the sync alternative, so it will pull the changes at that point. I don't need to make the changes directly in the sync alternative. So anyway, I come over to Oracle. I'm just going to show you the tables over in Oracle. This is my little scratch pad Oracle database, and this is the data down here. I just put it in GeoRaptor just so that we can get an idea of what it looks like up front. So I've made some changes around here. That line there is gone, and there should be another line coming in over here or something. So if I go ahead and I run this now, so it connects up, it does the merging, it looks at the changes to determine what changes are there. Okay, it found 3 changes to cables and 1 change to supply points. It'll tell me more information in the Emacs session about the operations it's performing. But basically, when I come over to my Oracle database now, if I redraw the screen, okay, so that line's now gone. This one's new one's come in here. I won't do that. But anyway, basically the information's there. You can see it graphically rendering. It will allow me to edit it, but basically I've removed a secondary conductor here, added a new one, added in a customer point. The table, the data that comes over into Oracle, typically we have an Oracle sequence. Here an Aura ID is a sequence number that's being used for these features. So I'll look at supply point. So basically, the new supply points in there. If I various attributes, etc., associated with it, the geometry is displayed as well. I also, because I'm synchronizing topology, if I go back over to here, I've got export topology as yes. So I get the nodes and the links coming out on the features as they're written out, and the Spatial plugin, which is our Oracle plugin. That's actually developed in Java. It's told to, basically the way that this process is it will take those changes and it will apply them as insert, update, and delete based on the FME DB operation of features that are sent into the workspace. So the SpatialBiz plugin detects that it's an insert, update, or a delete to a feature. It tags it as such within FME. When the feature hits the writer, the Spatial plugin, it says, okay, you're an insert, you're an update, you're a delete. I will do the appropriate thing with you. In addition, it's also told to model the data as a network, as a spatial network type. So Oracle has a number of network models it can support, a logical, spatial, topo. We really only support the spatial model. So basically, data comes out and it will go into our Oracle tables. So these are standard Oracle tables, link and node. We actually enhanced them a little bit to add in some additional information, a feature table and a feature ID. Although this is not strictly correct all the time, because there may be two features that share this same link, or on the node side, there may be more than one feature at a given node. So supply point, unfortunately the supply points don't actually have an ID number, they're a string which doesn't get saved in that. But this basically is just telling me that this is you know, the nodes and the links. We also then have a reference table which will hold information that is definitive, that says cable with an identifier of whatever the number is or the name is, string there is, and its geometry called center line, has a node which is 93896, and it's sequence number 1 in the list of nodes for this thing. So basically I can see here that cable 938963 has two nodes, a 0 node at the beginning and a 1 node at the end. This is my reference that says if I need to know from the nodes or the links, I need to get back to the feature that owns this or uses this, or multiple features that may use this. This is how I go and do it. I go through that reference table. That tells me then who is referring to the nodes and the links. So we have trace engines that can trace through, obviously, through the network model, and basically then can leverage this reference information. So you could put predicated tests in your Oracle tracing environment to say, I want to trace out from a substation to all the customers, and you can't trace through any switches where the status is open, well, yeah, when the blades on the switch are actually open. Alternatively, you could actually add that information in as an attribute on the link table directly, so you'd be able to use that if it's something you were commonly using. But normally we just add a few attributes in here, maybe the circuit ID, maybe status, and then just for quick reference, a feature table, feature reference, or something like that as well. But basically these are standard Oracle network model tables, and then this last one, the ref dollar, is one that we add, the Spatial, our Oracle Spatial plugin writes data back with. Okay, so that's that one. I'm going to do I've got one more workspace to show, which is basically a writer workspace at this point. So we've been reading data out of Smallworld all the time. So now we can just do a writer workspace. So import customers. So basically, so what we have here, I took some data out of Smallworld, and I wrote it to an FFS file, and now what I'm going to do is read it back in from that FFS and write it back into SpatialBiz, into the Smallworld tables. So there's where to write the data. It will be written to this alternative FME test write, usual local host and identifier, or server and service identifiers that are needed. Writer mode. So actually, we'll look at this user and password. So basically, it works with the reader as well. You basically can enforce that users have to log in and provide a password, user ID and password, before they are allowed to do operations of reading and writing data. So if you wanted to provide a very generic access to your Smallworld environment, you could do that. And then if you had a certain number of users who had the authority to read from a certain table, you could set that up in the authorization system against their user ID, their Smallworld user ID, or write to a certain table as well, set that up in the authorization system. And then in order to be able to do that, the authorization would need to be set such that they were logged in as that user, in which case you would pass that information in here, and it would be then logged in as you connect it to the Smallworld system. Writer mode is, in this case, is merge. So what this means is, there's a number of modes: insert, update, delete, and merge. So merge just means if the record coming in says it's an insert, update, or delete, you will perform the operation associated with that insert, update, or delete. If the writer mode is insert, it ignores the operation and just will try and insert all of the features coming in. Okay, so what I'm trying to show with this workspace here is basically writing data to Smallworld, which is reasonably standard, but the more complex operation here is relationships, is joins. So if I go over to my Smallworld system, okay, this one doesn't have a customer on it, but basically forging relationships to have a parent object, a supply point, have a relationship to a child object, a customer, where the child object and the parent object have keys which are potentially auto-generated. As I'm reading data in from an external system and I'm writing, that data would have correctly defined relationships within the source system, but when the data goes into Smallworld, at the point of insertion within Smallworld, if it's a unique key, a UVA, sequence-generated number, when that data gets loaded, the sequence number will be scrambled. So when it comes to actually writing the data back in, where this supply point may have been related to a customer previously, now, because the supply point has changed ownership or changed its ID, the customer doesn't necessarily know that it has the right ID for the supply point it's supposed to relate to. So this workspace, in a somewhat laborious fashion, is attempting to show that what we can do is, through the use of some macros within the workspace, we can enforce that relationships are to be followed. I'll talk about Feature Blocker in just a minute, but basically what I have is I have exposed supply point ID as an attribute, an integer attribute, which basically in my source data has been set up such that it points to the ID of the supply point. So the data coming in actually has the relationships truly defined in the source data. When the supply point goes in, its ID will get regenerated. The customer goes in, its ID gets generated. The supply point will lose that relationship at that point. So what we have here is this supply point attribute. This is a, don't want to show that. This is a constant which is being set to this attribute here. Supply point is the join field on the customer object. And what I'm saying with this macro called Record Finder is, Record Finder, I want you to find a supply point where its ID is equal to the supply point ID on the record that's being sent in. The result of that query should be put into the field supply point, which is the join relationship. So basically, by defining this Record Finder, what it allows me to do is say, go find the supply point that was created, find what its new ID is, or find where its ID is equal to the old ID, get its new ID, and put it into this field here, and basically take that object and assign it. So by doing that, what it's able to do is look up the sequences that say, okay, the record when it first came in was called 123, it's now called 456. And because it's now being renamed, I can get that new key value and assign it in correctly. The feature blocker, you'll appreciate that this whole process works on the basis that the parent goes first and then the child has to come second. So if I try and find a supply point, but I haven't processed any supply points yet, I won't be able to find it because it won't have been run through the workspace. I'm not necessarily guaranteed of order of collections and features as they are sent through a workspace. It basically depends on how they're placed within the workspace in the first place, or how they're read, and various things can come into play. So what that means is that if I want to enforce this relationship, I need to make sure that all of the supply points get processed first and all of the customers get processed second or after. So what Feature Blocker does is you connect up two sets of features. It guarantees that the blockers will all be processed and sent, and only when they've all gone will the blockees be released to go through. In this way, I'm guaranteeing that all supply points will be finished completely before it even thinks about trying to process a customer. Okay, so I'm going to go up to my alternative now, FME test write. Okay, so I believe the change is just to add some more data in around here. So basically, if I go ahead and run this, yeah, I'll redirect it to the inspector first, just so we can see what's in the data. Okay. Yeah, okay. So basically, what I'm doing is just adding this one here. This new record here is stored within the source data, and it has a relationship to its customer, etc., in that data. So if I now go ahead and execute it, okay, so it read a number of records. If I look in the magic prompt, just so I can see what's going on over there, it will show me that it's on the cable table here. I don't know if you can see this very clearly. It's kind of pink on pink. Processed 76 records, executed one insert, created one geometry, and then on the customer, it inserted one record, didn't have to do any geometry on that, and then it did something with cables up here as well, supply points, whatever. So the supply points had one insert as well. So basically that change has been made into that alternative. So if we go and have a look at it, okay. So I'm not seeing anything at the moment because this was actually done to a replicated view. So I need to just make myself or roll forward in that view. So I can click on this button here, roll forward. Okay, and I see the record come in there now. So now when I click on it, okay, yeah, so I've got all the topology set up as well for it. And now if I click on the customer or the supply point, you'll see the customer relationship is forged such that I can go to that record and look at the new customer information that I loaded into the through that relationship. So that's about it, really. That's really what I wanted to kind of show you, is just the reading, writing, basically interaction with the workspaces. We have a lot of parameters available, and then we also have basically a lot of customization or configuration settings that can be defined within the plug-in Magic server as well, such that you can control various aspects of how it works. Okay, so I am done on the demos.
Okay, well, thanks, Annie, for that. I have one question out of the chatterbox.
Okay.
What is the supported Smallworld version, or which ones?
Okay, so we can support. We have customers at 3.1 SP2 up to the current release. So we try and maintain compliance with all versions from 3.1 SP2 all the way up. Maintaining that for 3.1 is getting harder and harder, but we still do. So, but the majority of customers we have are on SWAF-based clients now, implementations.
Okay. Would you let me share my screen again, if you are done. As we are slightly early, I would basically like to, show a last slide where basically some email addresses are presented, so that we can, that people can basically ask questions afterwards.
Yep.
So can you see my slide already? Oops. All right. So, well, yeah, thanks for attending. In case Andy has nothing left, we're basically done. I would like to thank you for attending the webinar. As already mentioned in the beginning, we will send out a follow-up email with a webinar link and some material in it. In case you have any questions regarding the webinar or anything else around this webinar, don't hesitate to send us an email. You see both our email addresses, and yeah, we will be glad to answer your questions. So yeah, I think that's it. So thanks for attending, and well, have a nice day. Bye-bye.
Bye-bye.